all, in this video we will cover the topic of kinetic and equilibrium. So let's start. In part 1, we will focus on chemical kinetics and factors that affect the rate of reaction. Chemical kinetics is a branch of chemistry that concerns itself with the speed of chemical reactions, known as reaction rates, and the way in which these reactions occur, known as reaction mechanisms. To understand chemical kinetics, let us consider this reaction, where 4 molecules of ammonia reacts with 5 molecules of oxygen and make 4 molecules of nitrogen oxide and 6 molecules of water. Chemical reaction occurs in a series of simpler steps involving the collision of one or two particles at a time. These intermediate steps, which are also called elementary steps, are usually not observed, but they contribute to the overall reaction. Suppose that the reaction where A is a reactant and converts into the product B consists of 3 elementary steps shown below. In first step, A converts into the product I1, which is an intermediate product, and it is a fast step. In second step, this intermediate product I1 converts into second intermediate product I2, which is a slow step. In third step, this intermediate product I2 converts into the product B, which is a fast step. So what will be the reaction rate of this reaction where A converts into the product B? I1 and I2 are intermediates that are not observed when reactant A is converted into product B, and the relative rate of each step is given above the arrow. Of the 3 elementary steps, step 2 has the slowest rate and it determines the rate of the overall reaction. In technical terms, step 2 is called a rate limiting step. It serves as a bottleneck for the other steps, much as a narrow strip of road serves as a bottleneck for traffic flow on a major highway. Factors that affect the rate of reaction. Chemical reactions occur because the reacting particles collide with each other. The speed of a reaction depends on the number of collisions and the fraction of those collisions that are effective. For a collision to be effective, the particles must have enough energy and they must be oriented properly. Any factor that increases the number of effective collisions will serve to increase the rate of the reaction. There are 5 factors that affect the rate of reaction. First of them is nature of the reactants. Second of them is the concentrations of the reactants. Third is temperature. Fourth is surface area. And the fifth is catalyst. The first factor which affects the rate of reaction is nature of the reactants. Since bonds are broken and formed in chemical reactions, the bond types of the reacting substances are an important factor. In solution, ionic compounds tend to react more quickly than covalent compounds because fewer bonds need to be rearranged. For example, the reaction between iron in solid state and oxygen in gaseous state, which is also called the rusting of iron, is rather slow at room temperature, whereas the ionic reaction between AgNO3 in aqueous solution and NaCl in aqueous solution is extremely rapid. Second factor is concentrations of the reactants. As the concentration of a reactant increases, the number of collisions increases and the rate of the reaction generally increases. For example, in the laboratory production of hydrogen gas, zinc reacts more rapidly with 1 molar solution of HCl than with 0.5 molar solution of HCl. In a system in which gases react, the pressure is directly related to the concentrations of the gases. Therefore, an increase in pressure leads to an increase in reaction rate. Temperature. An increase in temperature increases the average kinetic energy of the particles, ensuring the number of effective collisions will increase. Therefore, an increase in temperature always increases the rate of a reaction. Surface area. As the surface area of the reacting particle is increased, the number of particles that collide is also increased. The result is an increase in the reaction rate. Catalysts. Catalysts lower the activation energy by providing an alternative pathway, therefore increase the speed of the reaction. In our next video, we will cover topic of reversible reactions in dynamic equilibrium. So don't forget to subscribe and like.